So in our third video on rounding, we're looking at significant figures. So in this video we're going to go over what is meant by place value, rounding to place value, what is rounding to significant figures, the method around rounding numbers to significant figures, error bounds, and using significant figures once you've calculated an answer. Now, rounding to significant figures, although it's classed as probably the highest level of rounding that you can do, it's actually connected and quite closely connected to the most easiest level of rounding, and that being rounding to place value. So on the screen you can see that we've got 4 questions, and you may have come across these questions maybe earlier in your years or at primary school, and so let's just have a quick refresh of what these questions actually mean. So if we were asked to round the number 12 to nearest 10, then basically what this question is asking is if we list our numbers of 10 starting at 0, and as we have here, so out of the 10 going up in tens, which 10 is 12 closest to? So imagine 15 is going to be here, so 12 is going to be on this side, so the answer there would be 10. For the second question, we're going to round 3,475 to the nearest 100. Now when you're rounding, it's always really good practice for you to read the numbers out loud. So here we've got 3,400, 3,500, and again what I'm doing is I'm starting off with whatever digit is written and then going for the next digit up, and then from here all I'm going to do is decide whereabouts does this number lie. So 3,475 lie on this number line. It's going to be somewhere around here, so the answer there will be 3,500. For the third question, so here we've got a long decimal number, so again it's really good to read these numbers out loud. So we're going to round this number up to the nearest thousand, so this number is 338,264.387. Now the decimal part doesn't really make an impact based on what we're rounding it to, so we want to round this number up to the nearest thousand. So we're looking at 938 with 3 zeros and 93930, so rounding up to the nearest thousand. So again, I want to decide whereabouts does this number lie. It's going to be somewhere along this side, so the answer will be 938,000. And then for the fourth example, so here we're looking at the hundredth, so we're looking at this 8 digit here. So again, we're looking at 0.38 and 0.39, and again if we want to write some zeros just because we've got it to 4 decimal places we can do. So again we're looking at what number is 3,864, you could say as equivalent. Well, that's going to be close to 0.39, so the answer there would be 0.39. And as we said, rounding to significant figures is a very similar technique. Now the difference with rounding to significant figures and rounding to place value is the fact that it kind of tells you in worded form when it comes to place value, where with significant figures that's something that you're going to need to figure out. Now before we go forward with working with rounding to significant figures, it's really important that, as I said earlier, that you can read numbers out. So understanding place value is really key. So in maths, particularly at GCSE level, you won't be dealing with extremely big numbers, but it's still important that you're able to understand what these numbers are. So for example, here you can see on the board, on the screen, sorry, that you've got quite a large number including going into decimals, and again it's really important that you're able to understand what these numbers are. So for example, if you had, let's say, 100th, it's knowing that that is 1 over 100 as a fraction. 1,000th is 1 over 1,000th. 10,000th is 1 over 10,000, and so on, and the pattern kind of resumes. And likewise it's important that tens has got 1 0, 100 has got 2 zeros, 1,000 has got 3 zeros, 10,000 has got 4 zeros, 100,000 has got 5 zeros, a million has got 6 zeros, and again using the commas after every 3 digits from the left going to the right, going from the right to the left, kind of helps you decide what it is we're actually going to do. And then 100 million, and it's got 8 zeros, and then a trillion is what's got 9 zeros. 2, 3. There you go. And it's always important that sometimes with place value questions, it came up in an exam that one of my classes did, where a question might say, represent what this 2 here represents. Well, that represents 100th. Now, as it's 200th, then that would be 2 over 100. If it was representing, let's say, this 7 here, well, that represents 7,000, so that would be 7,000 there. So it's always important that when you come to place value, even you may class it as a really basic of topics in maths and something you would have done when you first started counting even, it still has its comeback with latter topics. So let's actually have a look at looking at how do we round with significant figures. So if we take the number 234,985, which digit holds the greatest value? Now, that question you might think to yourself, well, okay, we're looking at digits, so I'm thinking the 9 is probably the biggest digit that we've got, when actually it isn't. Because the 5 represents units, the 8 represents tens, the 9 represents hundreds, the 4 represents thousandths, the 3 represents 10,000, and the 2 represents 100,000. So actually, the digit that holds the greatest value is going to be the 2, because that represents 200,000. So although 9 is the greatest digit, that only represents 900. So given a choice, if you would want to win £900 or £200,000, you're definitely going to go for £200,000. So looking at this, and that's one of the key things you need to look at. So when we're talking about the greatest value, the 2 represents the digit that is the most significant. It's our first significant figure. The 3 is our second significant figure. So let me just get rid of all of this, and we can put that in terms of what we're calling and rewriting this. So the 2 is our first Sig Fig, because that's the number that holds our greatest value. The 3 is our second Sig Fig. The 4 is our third Sig Fig. The 9 is our fourth Sig Fig, and so on. So significant values or figures act in a similar way of asking the same question. So for example, if we had, now again, reading these numbers out, again, it's a bit like a telephone number, but started with the dashes certainly makes it easier to read. So here we've got the number of 4,890,742. So with question A, it's asking us to round this number up to the first Sig Fig. So my first Sig Fig, if I'm using different colours, let's just get the rubber out. Is that not working? There we go. So rounding this number, so first Sig Fig is the 4. Now what I'm saying is basically what you should be thinking. So that 4 represents 4 million. So I want to round this number up. So when I'm asked to round to 1 Sig Fig, I'm looking at the first Sig Fig, which is a 4. What does that represent? Millions. So what's this number to the nearest million? Well, that's going to be 5 million. For the second Sig Fig, well, that represents the 8, and the 8 represents 100,000. So I want to round this number up to the nearest 100,000. Well, that's going to be 4,900,000. The third Sig Fig, which represents 10,000, so I want to round this number up to the nearest 10,000. So let me just write down what we're actually rounding this to. So that's 100,000. So our third Sig Fig, which represents 10,000, so I'm going to round this number up to the nearest 10,000, and that would be 4,890,000. So that's the nearest 10,000 we round this up to. The fourth Sig Fig represents thousands, so I'm going to round this number up to the nearest 1,000, and that's going to be 4,891,000. The fifth Sig Fig represents hundreds, so I'm going to round this number up to the nearest 100, so that's going to be 4,890,700. And the sixth Sig Fig, which represents tens, So I'm going to round this number up to the nearest 10. So that's going to give me 4890740. Now, doing it at face value is going to be quite difficult for you to understand. You're probably thinking, well, how have I actually worked that out? But again, there is a certain method that you can kind of use just to get you started on what it is we're actually going to do. So let's have a look at that method. So rounding significant figures. So what makes rounding Sig Fig more difficult is that the significance of each digit for any number keeps changing depending on how many digits there are in the original number. So for example, in this particular question, in this number here, we've got 2,458. My first Sig Fig equals 1,000. My second Sig Fig represents 100. My third Sig Fig represents a 10, and my fourth Sig Fig represents a unit. So you can see, and it only goes up to 4 Sig Fig because I've only got 4 digits in this number. Now when it comes to our second number, which in this case we've got 930,364, my first Sig Fig in this particular number is 100,000. My second significant figure is 10,000. My third Sig Fig is 1,000. My fourth Sig Fig is 100. My fifth Sig Fig is 10, and my sixth Sig Fig is a unit. So depending on, and the reason why it goes up to six significant figures is because I've got 6 digits in this number. And as you can see, that the first Sig Fig in 2,458 is different to the significant value or the place value of the first digit in the number 930,364. And likewise, if we move on to our third number, which is 76.62, here our first Sig Fig represents tens, our second Sig Fig represents units, our third Sig Fig represents a tenth, and our fourth Sig Fig represents a hundredth. So these are the questions you kind of need to ask. You need to look at the first digit or the first non-zero digit, which I'll talk about in a second, and then that go from there, which holds the greatest sort of value, or in this case, significance. So as I said, there's a certain method that you can use if mentally you're kind of struggling to get your head around this. So let's have a look at that method. So let's say we're going to round the following. So in this particular number, we've got 456,782. And in this question, we're asked to round this number up to 1 Sig Fig, 2 Sig Fig, and 4 Sig Fig. So the first thing we need to look at in terms of these steps is ignoring any starting zeros and starting from the left, underline the required number of digits according to the rounding requirement. Now that sounds a bit of a mouthful, so let's have a look at what I actually mean by doing that. Well, it'll certainly help if I've got the right pen. So looking at A, if I just write down the number again, so here I'm going to round this number up to the first Sig Fig. So what I'm going to do is I ignore any starting zeros. Now in this number here we've got no starting zeros, so I'm just going to underline the 4 because I've got 1 Sig Fig. Now from this, what I then want to do is circle the digit next to the underlying number. So my underlying number is 4, so I'm going to circle the 5. And then the third step then says if the circle number is bigger than 4, we need to add 1. If the circle number is 4 or less, the underlying number stays the same. So in this case, our circle number is bigger than 4, so I'm going to add 1 to the underlying number, which then becomes a 5. And then the fifth step then says change all numbers outside the underlying number to 0. So here I'm going to just do 1, 2, 3, 4, 5, and there is my final answer. So let's try that for B. So with B, we're going to round to 2 Sig Figs. So again, what I'm going to do is I'm going to write the number out again. Now in this case, I want to round up to 2 Sig Fig. So ignoring any starting zeros, which again we don't have, I'm going to underline the first 2 numbers from the left that we need. The next step is then to circle the digit next to it, which is a 6. So the underlying number is 45, the circle number is 6. Now step 3, is the circle number bigger than 4? Well, yes it is. So I'm going to add 1 to the underlying number, so that becomes 46. And then I'm going to change all the other digits to zeros, giving me an answer of 460,000. And then finally for 4 Sig Fig, so let's write the number out again. So to 4 Sig Fig, I'm going to underline, ignoring any zeros at the front, which again I haven't got. I underline the first 4 numbers and I circle the 8. So here what we're going to look at is, as the circle number is bigger than 4, we're going to add 1 to 4,567, which gives me 4,568, and then change all the other numbers after the underlined number to zeros, giving me this answer here. So like I said, this method is kind of a structured way of doing it. Would I recommend it? Once you've mastered it, you don't need to do it. Hopefully with a bit of practice you'll be able to do some of these questions in your head. So let's have a look at some other examples. So let's have a look at these questions. If you want to have a go at, if what I've said makes sense, have a go, pause in the video and have a go at these questions. If not, I will talk you through these examples. So again with question 2, let me start off by writing the number out, just so I'm not completely decimating the question. So in this we're going to round up to 3 Sig Fig, so I'm going to underline the first 3 numbers, ignoring any starting zeros, which again in this case we don't have. I'm going to circle the digit next to the underlined number, which is 29.3. Now when it comes to adding 1, now technically we're not going to add the unit 1 to this number, because then that will make it 30.3. So what we're going to do here is we're just going to add 1 to the next level up. So here, because 8 is bigger than 4, I'm going to add 0.1, so that becomes 29.4, and then change the other 3 numbers to zeros to give me 29.4. Now in terms of those zeros here, they're not doing anything, so I'm just going to write my answer as 29.4. For question 3, so here we're rounding up to 2 Sig Fig, so again I'm going to underline the first 2 numbers, ignoring any starting zeros, and we're going to circle the 5. Now as 5 is bigger than 4, I'm going to add 1 to the underlined number, which here is 20. So here I've got 21, and then all the other numbers turn to zeros. And there we go. Now the reason why I'm not ignoring any zeros here is because I've got no decimal point. So writing these 2 answers is absolutely fine, but this answer here is probably the most preferred one. Now if you are thinking, well, what's this ignoring by zeros? This is where it comes into question 4. Now with question 4, we've got some starting zeros, so I want to ignore that. So what I'm going to do is I'm going to focus on this 43, and I'm going to circle the 8. So here the 8 is bigger than 4, so I'm going to add 1 to the underlined number, which then becomes 44. And again, I'm then going to change all the other digits into zeros. So here, just to double check sure I've got another 0 to add. And there we go. So here the correct answer for this one is going to be 0.044000, or I can write this much better because we ignore any zeros at the end after a decimal point, which gives me 0.044. Now finally moving on to question 5. So here I've got no starting zeros and I'm rounding to 3 Sig Fig, so I'm going to underline the first 3 numbers, which in this case is 399, and I'm going to circle the 5. So here, as you can see, 5 is bigger than 4, so I'm going to add 1 to 399, which makes it 400. And then I'm going to change all the other digits, to 0. So that's 12.000. And again, ignoring any zeros at the end after your decimal point, so that then just becomes 40,000. And there's your final answer. Now, as I said, this method of underlining and circling has its constraints, because obviously if you look at example 2, we're not literally adding 1 to 29.3. It's just a case of increasing the sort of place value, which is why it's quite confusing. So the way to understand this particular topic is certainly to look at place value. So for example, if you look at question 5, our third significant figure is the 100th. So we want to round this number up to the nearest 100, and that's how you want to be thinking. In question 3, again, we're rounding up to 2 Sig Fig. So our second significant figure number there was to nearest 1000. So you want to round 20,566 to the nearest 1000. So that is a much better way of understanding this topic. But obviously the underlining and circling is certainly a way that you can kind of develop that understanding with practice. So let's have a look at another question. So here we're going to round this number up to 2 sig fig. So again, I'm going to underline, so the second sig fig is this 9, and that 9 represents tenths. So we want to round this number up to the nearest tenth. So again, I'm looking at this and underlining the circle number. So I know that 8 is bigger than 4, so I'm going to increase 2.9 by 1, or 0.1 I should say, so it becomes 3.0, and then all the other 3 digits become zeros, leaving me with an answer of just 3. So again, why this, again, just to reiterate, why this topic is classed as a high level of rounding is simply because it keeps changing. Unlike decimal places, where you just count the number of digits after a decimal point, there's certainly a lot more sort of understanding and variety that you can get as rather than having a strict method when understanding this particular topic. So let's have a look at with error bound. So we've mentioned this when we looked at rounding to decimal point, is what is meant by stating the error bound. Now for this, what the error bound is going over, so I kind of mentioned it in the video of decimal places in the last video. So what this is saying, what range of values could a number be that when you round it to 3 significant figures, the answer will always be 23,400. So with this, what we're looking for is to state the error bound. Now we're rounding up to 3 significant figures. Now our third significant figure is 100. And I'll just write 100. Now as we're rounding up to the nearest 100, then I'm basically looking at plus and minus 50 in either way. So for this, so to find our lower bound, all I need to do is do 2,400 take away 50. And to find our upper bound, I need to do 23,400 plus 50. So this is going to give me an answer of 23350. And this is going to give me 23450. And so if I was to round up, so our error bound is going to be 23350x, and it can equal that number, because if I'm going to round this number up to 3 sig fig rather, it's going to give me this number here, and this is going to be my upper bound. Now it can't actually equal 23,450 because that would round up to 23,500. So in order to get for this number, I don't need to underline that inequality sign. So this here would be our error bound. Now, as a standalone topic of rounding, significant figures also comes into play when it comes to working out other calculations. So if we move on to, let's say, using a calculator, say for another topic you're asked to work this out, and this topic kind of tests a range of mathematical skills and topics. So this is basically testing your ability to use a calculator effectively and look at rounding, which you might find in certain exam papers. To answer this question, what we need is going to reach out for our calculator and we're going to enter this number in. So now again, making sure that hopefully you've got a 2-line display calculator. So if you have got 2-line display calculator, makes these types of questions very easy. So what we've got to make sure is we're doing is, as you can see, we're entering the question exactly how it's going to be shown on the calculator, or actually vice versa from that. So we're going to do 3.4 cubed times, let's get rid of that, so we need to scroll across, times the square root of 67.323, and scroll across, plus, and then get our fraction button of 13 over 24. Now as you can see, it's with these complex calculator questions, we need to make sure that we've not made any mistakes, and as you can see, what's shown on my calculator is exactly how the question is written. So once I'm happy with that, I'm going to press equals, and I get the answer of 323.0333219. Now in this question, it's asking me to write the answer that's rounded to 3 significant figures. So looking at the calculator screen, I can see that my first non-zero number, or my third non-zero, or my third non-zero number is 3, the second 3. And that 3 represents units. So what I want to do is I'm going to round this number up to the nearest unit. So from that, I can see then the answer for this would be 323. So again, when revising this particular topic, it does link in with other topics, particularly with other calculations, but it's really important that you understand place value and also be able to read numbers out aloud. And so before you even master this topic of rounding to significant figures, do make sure that you totally understand place value.